So, we're getting a feel into what mathematicians or physicians or physicians or astrophysics or astrobiologists mainly visualize when we're talking about interstellar. And when we're studying these stars or supernovae, we are able to attempt to visualize what is out there. Okay? So, starting off with, say, if you were to draw a line, that would have been a one-dimensional drawing, and drawing a square would be a two-dimensional drawing, where a cube would be a three-dimensional object. And just to think about these shapes, to base off of some theories and some studies that have been shown or been seen through. Okay, so when we think about dimensions, not only can we think about shapes as well, we could also think about the way that we can have a perspective of things. But yes, if you want to look into more examples, let me know. Okay, so around the 18th to 19th century, there were studies, and here we go. If we start with the first piece, cardinalities, George Cantor, they were able to try to explain how, say, a line is made up of something. What is a line made up of? Here, cardinalities, he explains how a line consists of these tiny, tiny dots. All of these dots make up the line that makes the one-dimension drawing. In this case, he also uses this theory to establish a two-dimensional drawing along with a three-dimensional object. Say, a two-dimensional object, a two-dimensional drawing, is made up of these same tiny dots. These same tiny dots make up this square. And with an object, a three-dimensional object, all of these tiny dots make up this cube. Along with piano, he established some photos here. He goes more into depth how there are this is an example that makes up this picture, and so on and so forth. And it was to show how this first picture can make up pictures like these, and so forth. The problem with those two theories was that it was kind of disordered. It's not much of something that you could really measure off of. It almost invalidates itself, as there is no way that a one-dimensional shape can also be made of the same things as, say, a three-dimensional shape. And that goes into L.E.J. Broers. He kind of establishes that argument as well, because he does claim that, over here, he talks about how the bigger dimensions can't fit into the smaller dimensions, and therefore a 1 dimension compared to a 3 dimension can't be compared against a value, really. And I took this note, n dimension space, or n minus 1 dimension. This is his example, or an example that I found that that shows what his claim was. As you can see, we have these circles within this square, and these spheres within this cube. If these cubes, or if this square were to expand, these same spheres that would try to, these same circles that would try to expand to the new size of this square, it would not be able to fit within the cube, because it would actually grow out of the shape of the square. To further conclude that bigger dimensions can't fit into smaller dimensions. If you have any questions, please let me know. This concludes this presentation about dimensions, and I think it's pretty spot on about how fascinating this study is, really. And I'd like for you to remember this cardinalities, really, and just how really it just got started and all, and analyze these pictures too. These probably help a lot. In this next presentation, I could also go into more so just like the broader purpose of these dimensions. I could also go into the larger dimensions, such as the 4th dimension as well. So far, most of the dimensions that are studied can't be physically seen in the human eye, that yet there are people that comfortably study 4th, 5th, 6th dimensions. And it's pretty fascinating, and it's pretty cool, and I did find this study to help me grasp more knowledge about the living of stars, and how stars are among dust, and how this dust and this gas can develop and create these it's kind of similar to like a Big Bang, sort of. These gases, they make up a bunch of new stars and binary stars, and this is something pretty good to learn off of as well. Thank you.